Guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 680 valid palindrome second. You can do the valid palindrome first on your own. It is a very easy question, and I would highly recommend you should do that also. And you know the drill. You should read the problem statement, at least give problem 15 or 30 minutes, and you know when you are not able to get the solution, or you want to find the intuition, you know where to look. That is complex YouTube channel. So let's get into the question, shall we? So what problem is saying, by deleting one character, can the string be a palindrome? Let's take an example, see for ourselves. B. No, even if we delete this and this, for example, we delete this, our pointer goes to this, it's okay. Then our pointer goes to this and this. Already we have deleted one time, so bad luck. Or if we delete this again, bad time. Let's take a better example. A B A C A D A, palindrome up till now, not palindrome. Delete this pointer get to this, still not palindrome. So even if we have other case, if we delete this and the pointer get to this again. Let's take one more example to have more clarity, because it you can do this question by just taking an example on your copy, and just getting that intuition into our code, not intuition, that thinking, the way of thinking into the code. That's it. This question is very simple. Implementation, it it may be marked as easy, but it is a founding question. A C A B A, palindrome, and palindrome. It is a palindrome. Let's take another case where deleting one will lead to a correct solution, but deleting other will not lead to a correct solution. Let's try to make that test case. Uh, Take it as delete this. Yeah, this could be the example. Yeah, this could be the example. This could be the example. This, yeah, AA, it's D. AA, palindrome, B, D. If we delete this B, we get to this. Still we encounter same, not palindrome, but let me write again for clarity. This. But this time we'll delete this. Pointer goes to this. This is palindrome. Both the pointer at this, palindrome. So we have discussed all the cases where there will not be a palindrome, where it will be a palindrome, basic normal condition, and this condition. Similarly, you can make a solution where, not a solution, a test case where you delete this one and preserving this one, you lead to a answer. So let's, I think you get what problem is trying to convey. So while doing this, one intuition should come to your mind. What is the intuition? Not the intuition basic thing when we want to see if one thing is palindrome or not. Palindrome basically means if we bisect it into two things, this and this will be same, this and this will be same. So in order to do this, you need two pointers. But also, if you have done recursion, you will also get that hint. Yeah, we can apply recursion. How? If you carefully do this test case on your copy, you will get to know that you have two choices. Whenever there is a choice, recursion, my favorite thing is recursion will handle. You can do this, but it is little bit, if it comes in your mind, then good. May or may not come. This this intuition, you can, if it come, if it comes to your mind, then you can hopefully make a base case and get the answer. Base case also, careful careful calls. What is careful calls? I mean, no out of bound. So let's discuss recursion because it is pretty much easy. Recursion one. Recursion. In recursion, what we are doing is, if they are equal, there will be a return. All this with I plus and j minus. If this doesn't happen, then we will have a count variable. If it is 0, why we are having a count variable? Because in this case, as you can see, uh, because in this case you can see first delete, then again same thing happen. So only one delete is allowed, at most one, 0 and 1, at most one delete is allowed, at most one delete, at most one delete is allowed. So you get what I'm saying. So we will have a count which will uh, decide whether it is a viable delete or not. Then there are two calls. Why we are putting or? Because in either of the case, if true returns, we return true. In or condition, in order to have one at this position, either here is true or either here is true, or even both condition true, we will have a true. So in this condition, we will ignore the first one. So keeping the end same, start increase, keeping the start at the same position, decreasing the end, and see for ourselves if they are returning or not. Else, if all the things happen and still nothing fruitful is found, then you have to return false because nothing worked. It is not a palindrome. So that's the solution in base case. Base case over here. Base case is very necessary. The careful calls are done here. Now the base case. Base case is, it's like two pointer only. Return true if, this will return true if only if pointer, these pointer interchange each other. So I becomes greater than or equal to j. Return true. If you reach to this position, then it's game over. Now I will show you the recursive solution. This is the recursive solution. So our base case, our condition where both are equal, we will just increase the end, start, decrease the end. If this condition doesn't happen, we check this count, as I already discussed. Count plus one, count plus one. In this case, count will not increase. In these two cases, count will increase. Plus, in this case, we are ignoring or deleting the start. In this case, we are deleting the end. Now, and if all these cases fail, we have to return false. And it is a basic recursive call. That's it. Let me show you if it is running or not. Yeah, it is running. You can see for yourself. Let's get the last method of doing this question. It's two pointer. In two pointer, what will we do? Basically, first we will traverse. Basic for traversing, not for while. While, sorry, you can do with for. For basically, it is not easy to handle. In many codes, you will see for using two pointer using for in Lee and many lead coders solution. So we will have a while just traversing. If this condition is true, there is nothing to care about, just continue. But if this is false, this is not equals to this, what should we do? What were we doing here? We were deciding to use this case or this case, deleting the end or deleting the start. So we will just do that while using the loop, while same loop, while I is less than j, and see the condition. But we have to declare these I1, J1, I1 and J1, and we will just increase the I1 to J1 and J1. Similarly, if we have ignored, what is I1? I1 is I minus, sorry, plus 1. Ignored the 1. Wait, what is J2? J1, sorry. J1 is J. This case is ended here. This one. Start is updated, but end remains same. And J2 will be, I2 will be I, but J2 will be end decreased. We have to run loop for these two cases. If we run loop for these two cases, I2 less than J2. This is basically two pointer. Just one. This will come in one hole where the uh, false condition will happen when these two are not equal. Basic, and here we will be do the same. Now here comes the part. In this block only, here is it. Let in this block only, we will, if what we will do, if I1 is greater than J1, sorry. Why? This loop will only be terminated in two conditions. If this condition is false, or if this condition is false. If this condition is false, this thing must be happening. If this condition is triggered, this is not true, so this will never happen. It will be somewhere in between, and still I1 will be less than J1. Or same like recursion. If I2 is greater than J2, this is this is for end deleted. This is for start deleted. And in both the cases, if something is true, we will return true, and that's our solution. And at the end, we will return true after the loop. Why? Take the case now when this condition never happen, and we will just keep on iterating, and we come out of the loop. Then we should return true. So let's see the code for the two pointer. This is the two pointer code. Basic. I is start, J is end, I is less than J. This is this is a block where we handle our not equal case. This will be happening every time. If our condition is true, I is equals to Sj. If this is true, they are not equal. So first remains same, end is deleted, first is change, and remains same. We will do basic for loop, while loop on these two cases. Once end is deleted and once start is deleted, and we will see if in any of these cases these conditions hold true, and we return true. And after ending this, if this condition never hit, then also we will come out of loop, then we have to return true. False will happen when this condition is triggered. That's very basic. If you still have little difficulty, I will highly recommend to dry run this code. You will get it. It's a submitted solution. As you can see, 99.55. It was much faster than the recursive one. So I hope you have learned something. So let's, where were we? I hope you learned something. And if I did something wrong, you can put down that in comment, or if you have any doubt, also you can put that in comment. And see you in the next one, guys. You are great. Bye bye. Keep grinding.